Welcome back. We finished the last video by stating the theorem that a language is regular if and only if it's described by a regular expression. To prove this theorem, we decompose it in two lemmas. The first one states that if a language is described by a regular expression, then it's regular. To prove this, let's recall that a language is regular if and only if there is a non-deterministic finite automaton that recognizes it. So it's possible to take the regular expression and build a non-deterministic finite automaton for the same language. For this, we'll go back to the definition of regular expressions. Regular expressions are made of smaller regular expressions and regular operators between them. And for the smallest regular expression, which are A, epsilon, and empty set, we know the languages. The language of small a is the set containing A. The language for empty string is the set of empty string. And the language for the empty set is empty set. And we already know how to draw the finite automata for all of these regular expressions. We know that for the language containing a symbol A, it's sufficient to draw an initial state going to a final state with the transition A. For the empty string epsilon, it suffices to write an initial state which is also accepting. And for the empty set, we may write just an initial state without any possibility to go to an accepting state. As for the operators, regular expressions are made of concatenation between two regular expressions or union between regular expressions or the operator star applied to a regular expression. And as we may know, regular languages are closed under union, concatenation, and star. And we know how to draw the non-deterministic finite automaton for a concatenation of two languages, a union of two languages, and also for the operator star applied to any language. Let's explain more this idea on this example. Let's take the regular expression AB or A star. Here we need to decompose the regular expression into the smallest regular expressions and then combine them via the operators, the known regular operators, concatenation or union or star. Okay, as we may see here, there is A concatenated to B, and then we have a union between this part, AB, and another part which is A star. So here we may start by drawing the finite automaton for A and B. Okay, so we will have these two small automata recognizing the symbol A and the symbol B. After that, we may apply the concatenation. With the theorem known for the concatenation, it suffices here to draw the first part related to A and the second part related to B, and take the final state of the first part and link it to the initial state of the second part with the transition epsilon, and hence we will obtain the non-deterministic finite automaton for AB. Note here that the final state related to the first automaton is no longer finite here, no longer accepting state here. Then we may apply the star from the symbol A. So we'll take the automaton related to the language A and apply the star operator on it, which tells that from the final state we are going back to the initial state via an epsilon transition, and we are adding an initial state which is also an accepting state and will relate it to the old initial state via the transition epsilon. Now we have already the two parts, the first one which is AB and the second one which is A star, and now we may apply the union. So we'll take the first part and the second part and add an initial state going to the initial state of the fragment AB and going to the initial state of the fragment A star via the transitions epsilon. And here we obtain the non-deterministic finite automaton for AB union A star. Let's take another example here, which is A or B between parentheses star concatenated to A. First of all, we have to apply the union on A and B. So we have to draw the finite automaton for A, the finite automaton for B, and then draw the union for these two finite automaton, and we'll obtain this NFA. After that, we will apply the star on the result of the union of AB. We'll take the two final states and add transitions to the initial state via epsilon from this final state and from the other final state, and finally add an initial state which is also accepting in order to accept the epsilon string. After that, we will apply the concatenation to the two obtained parts, A or B star and A, and we'll let the three final states here go to the initial state of the second part with the epsilon transition, and the three final state of the first fragment, A or B star, will no longer be final. And here we obtain the final NFA for the regular expression A or B star concatenated to